Chapter 7 Summary. Complete Guide to LCD LED. VCOM Panel Voltages. Welcome to the 7th chapter of the free LCD LED TV repairing course. This session delves into the crucial world of panel voltages. We will explore all the different voltage types found within an LCD, LED TV panel, their names, standard values, the symptoms that appear when they are missing, and the repair strategies to fix them. The instructor begins by reminding viewers about the structured 25-chapter course and recommends checking a previous video outlining all topics. He also promotes a foundational book he authored over a year and a half, available in Hindi, Bangla, and English, which covers 15 essential electronic components, their function, identification, and testing to build a strong repair base. Core concept: the 8 primary panel voltages. While other voltages exist, 8 are most common and critical for panel operation. They are VGH, VG, AVDD, VCOM, VD, underscore, AVD, NG, AMMA. The names might slightly vary between panels, for example. VDDA might be labeled differently, but their functions and values remain consistent. 1. VGH, high gate voltage. Full form, V underscore gate high. Typical value, 20 volts to 35 volts. Function: controls the switching on of the TFT thin film transistor gates that activate individual pixels on the panel. Symptoms of missing: no display, double image, horizontal lines. Location depends on whether the issue is in the source or side. CO5 repair approach: check the sequence. CO5 TCON board section greater than LVDs, ribbon cables. Externally, a panel booster module can sometimes restore this voltage to VGL, low gate voltage. Full form, V underscore gate low. Typical value, -5 volts to -10 volts. Function: controls the switch in OFF of the TFT gates, turning pixels off. Symptoms: if missing, no display. Flickering screen picture rapidly turns on all. Vertical lines. Repair approach: focus on the COFIC check for shorts, the DC-2DC section on the TCON, and associated capacitors on the VGL line. 3. AVDD, analog power supply. Voltage: typical value, 12 volts to 16 volts. Function: powers the analog circuitry, including the source driver and the TFT pixel voltage for the analog section. Symptoms: if missing, no picture. Dim display, color distortion washed out or inaccurate colors. Repair approach: inspect the TCON fuse, DC-2DC section, and all components capacitors, resistors around the AVDD line for shorts. Clear any shorts to restore voltage. 4. VCOM, common voltage. Typical value around 5 volts, often adjustable. Function: balances the pixel voltage to prevent flicker and ensure uniform voltage across all pixels. Symptoms: if missing, incorrect, white screen. Negative image photo, negative effect. Ghost image. Repair approach: this is a critical voltage. It is usually adjusted via a variable resistor potentiometer or preset on the TCON board. An oscilloscope is ideal for precise adjustment. Faults can also line the dedicated VCOM generation IC or its associated resistors. 5. VDA, digital power supply. Voltage: typical value, 3.3 volts or 5 volts. Function: provides power to the digital ICS on the panel, for example. Timing controller, memory. Symptoms: if missing, no display. Panel initialization failure, no graphics processing. Repair approach: troubleshoot the DC-2DC converter section responsible for generating VD. Check for faulty components or shorts in this circuit. 6. VENG, input voltage. Typical value varies by panel size. Common, 3.3 volts, 5 volts, 12 volts, or rarely 19 volts for large TV. Function: the main input power supply to the panel. It feeds the TCON board, from which all other voltages, AVDD, VCOM, gamma, etc., are derived. Symptoms: if missing, no display to panel remains completely dead, no power circulation. Repair approach. First, check if power is arriving via the LVDS cable. If not, trace back to the mainboard's panel supply section. If power arrives at the T-con but doesn't proceed, check the T-con input fuse. A blown fuse often indicates a downstream short that must be cleared. 7. VDD. Logic power, supply voltage, typical value, 1.8 volts or 3.3 volts. Depends on the logic IC used. Function powers the programmable logic ICs or memory ICs, which may be separate or part of the T-con. This is crucial for the panel's brain or logic operation. Symptoms if missing incorrect: no picture, inverted, upside-down picture, garbled, corrupted, or half-displayed images. Deem picture. Repair approach: investigate the specific DC to DC section that generates the VDD voltage. Replace faulty components or ICS in this circuit OI to gamma voltage. Typical value, variable with multiple reference points V12, V14, V15. It creates a staircase voltage curve. Function: ensures color accuracy and grayscale linearity by providing precise reference voltages for different color levels. Symptoms if missing incorrect: inverted colors, specific color missing, negative image. Color distortion. Repair approach to main culprits. The dedicated gamma IC needs replacement, or the string of small resistors dividing the voltage between the gamma reference points. Bonus information: LVDS signals and measurement tips. LVDS signals. These are low voltage differential signals. For example, RXO plus, RX0, carrying video data from the mainboard. Their common mode voltage should be between 0 volts to 1.5 volts. Significant deviation usually points to a faulty mainboard main IC. How to measure: use a multimeter in DC mode. Connect the black probe to a solid ground. Touch the red probe to the marked test points, VGH, VGL, etc. on the T-con board to read voltage. Final practical tips for panel repair. Always check the T-con fuse first. A simple blown fuse is a common fault. Multiple missing voltages. If many voltages are missing simultaneously, you can try using an external panel booster module or harvesting a working T-con from a similar broken panel, but success rates vary. Oscilloscope is key for diagnosing signals like LVDs and gamma references. An oscilloscope is invaluable. COF chip on film issues, four-side or source COF problems. You can attempt jumper wiring or rebonding the IC, but these are delicate procedures. Often, the most reliable, though costly solution for a severely damaged COF is panel replacement, as a panel constitutes 70 to 80% of a TV's cost. This chapter provides a fundamental map for diagnosing panel-level faults by understanding the role and failure symptoms of each core voltage. The upcoming chapters will cover sourcing panels and delve deeper into specific topics like gamma voltage and LVD's signal analysis.